In this video, I will be talking about problem 3 in your homework. I'm not going to make a video for problem 2 because it's so similar to problem 1. It's just more practice. So I'll let you guys handle that one, and we're going to talk about problem 3, which is a little bit different. It still has to do with pollution, a negative externality, and we're given a schedule here of tons of emissions in the millions and what we want to think about this is as we spend more money, we are lowering the emissions. We're going from 50 million tons of pollution, which is the sulfur dioxide emissions, down to 0 tons, and that's going to cost more and more as we go. So that's the key here. These are marginal cost of reducing pollution and marginal benefit of reducing the pollution. Now, that means that we're not looking at total. Now, we're going to compute total cost, but this schedule and what we're going to graph is marginal cost, and very different. So if we look at this, as we reduce pollution more and more, going from 50 to 40 million tons costs $6 million. Going from 20 to 10 costs $36 million. Because as we clean up, it costs more and more to do even more cleanup. You have to buy more equipment, maybe install more advanced or sophisticated filters, all those types of things. So it gets to be more and more expensive as we reduce pollution down to 0. Now, the opposite occurs in terms of marginal benefit. We gained much more benefit by reducing from the large amounts down to sort of medium amounts. The gain is more, the marginal gain. So if you look at this, going from current levels to 40 million tons is a marginal benefit of $50 million. Going from 10 million tons to 0 tons of pollution is only a marginal benefit of 2 million. So you see how we don't get near as much at the end as we do at the beginning. And the way to think about this conceptually is if we think about tap water in New York City. In order for us to have clean drinking water out of the tap, it costs a lot of money to clean up water that's maybe even comes from a sewer or comes from some polluted area, or just not clean. So that initial filtering that they have to do in the cleanup to make the water drinkable is very, very expensive. And the benefit is great because we go from water that we can drink or can't drink to water that we can drink. My wife likes to have filtered water, so we actually have a filter installed on our tap that even filters it more. It's not very expensive, but really it's not so much about the cost. I want to talk about the benefit. So to do that extra, well, it would be expensive. No, I should take that back. If we think about it in terms of the whole city. If every single resident, if all 10 million residents installed this $50 filter onto their tap, that collectively would be very expensive. And what would be the gain? Well, my wife says the water tastes better. I can't tell. So I am just happy to drink water out of the tap without running it through the filter. So there's really, to me, anyway, there's not that much difference. So the marginal benefit for that extra filtering is a lot lower than the marginal benefit would be, for the filtering that the city does, which actually makes the water drinkable. So that's kind of the concept behind why these marginal benefits go down and the costs go up as we do more and more cleanup. Okay. So what we want to do with this is we want to first look at, well, we first want to draw our graph. So that's going to look like this. Okay, so we want to come down here and just look at our graph. Let me grab my little green bouncing ball here. So we want to have our marginal cost or benefits on the vertical axis, and we want to have our emissions starting at the high level and moving to the right down to 0 on our horizontal axis. And you just want to graph our marginal numbers from the table that you're given in the homework, which is right here. And then what is very helpful to do is compute the total cost and total benefit. And that's just simply done by adding up the marginal cost. So going from a 50 to a million cost 6 million marginally, and we started at 0, so the total there is just going to be 6 million. But then going from 40 million down to 30 million tons of pollution, well, the marginal cost there is 10 million. So in order to get total cost, we have to add that to the 6 million before, and then that gives us a total cost of 16 million. And of course, here for the total benefit, we're adding a 50 million and 32 million to get 82, and we just continue that all the way down to get our total cost and total benefit as we reduce from 50 million tons down to 0 tons. And then we want to compute our net benefit, which is simply done by taking the benefit dollar amount and subtracting from that the cost. And then we can see our net benefit for reducing at these different levels. And you can see at some point the net benefit starts to go down and then even goes negative. So the net benefit, when you look at cost and the cost, well, what we call the cost benefit analysis, if we were to reduce down to 0, the net benefit would actually be negative. So that's why we don't typically, as a society, do that. So what we want to do is we want to look at, well, we've already actually talked about what the intuitive reason that marginal costs rise as we reduce pollution, and the intuitive reason that marginal benefits decline as we reduce pollution. We talked about that with my water example. So at what point are marginal benefits and marginal costs equal to each other? And what is the significance of this point? Well, that's this point right here, right? That's what we can call a market pollution equilibrium. This is at marginal cost of 20 million. And this is where cost equals benefit at a sulfur emissions rate of 20 million tons. And if we go back up to our original schedule here, we can see it at 20 million tons. They're equal, right? Now, why we did the total cost analysis and the net benefits analysis is we can also see at 20 million tons at a marginal cost of $20 million and a benefit of 20 million, marginal benefit of 20 million. When we compute our total cost and total benefit, we see that our net benefit is highest. Now, you're going to ask, well, what about 30? It's high there too. Well, okay. And why do we choose 20 over 30? Well, the short answer is that's where marginal cost equals marginal benefit. But if we look at our graph again, and we just sort of play that out, when we go to 20 tons of emissions, that's where, if I can grab this guy, that's where marginal cost equals, let me just extend him out, equals marginal benefit. So they're equal. Now, if we were to go to 30 right here, that would be at a point where marginal benefit is way above marginal cost. So we're getting much more of a benefit for our cost here. So we can afford to we would want to reduce even more, because we're at a point right now where we have some room to reduce more because our benefit is well above our cost, so we could afford to spend some more money and reduce to a point where cost and benefit equal out. And that's what we kind of want to do. Now, if we reduce even more than that, say we reduce down to 10, what's going to happen there is this is going to be very, very costly and very inefficient, because at this point you can see cost is much more than a benefit, marginally, right? Marginally. And if we go back up to our total cost at 10, we can see that we've dropped in our net benefit. Our net benefit drops from 66 million to 40 million at 10. So it's easy to see that in order to get the maximum net benefit from our emissions, from our pollution reduction, we want to be somewhere in here, just quickly looking. But we also want to be at a point where we're the most efficient, and that's going to be where marginal benefit equals marginal cost, right here and right here. Get this calculated, okay? And I believe that takes care of pretty much everything they're asking you. Yeah, we talked about 10, and then we looked at what would happen if you went down. Let's see, why not have a law that just takes it down to 0? Well, if we go down to if we go down to a 0, let's jump back here, and I said this a minute ago, but if we go down to 0, grab my green bouncing ball, you can see that at 0, going from 10 to a 0 is a huge marginal cost. It's 60 million marginal cost, and the marginal benefit is only 2. So the cost is exorbitantly or much higher than the benefit. And we also see that the net benefit, when we compute total cost and total benefit, is actually negative. So that's why policy makers typically don't try to lower pollution down to 0. Even though it seems like, it's sort of counterintuitive, because it seems like, well, wait a minute, don't we want no pollution? Why would any pollution be good? Wouldn't it be worth it just to spend the money and not have any pollution at all? Well, if you go back to the water example and you sort of think about what would it cost over the entire city of New York to filter the water like we do in our house with that extra filter that we buy and install, that cost would be tremendous, and the gain would be, well, maybe some people would think the water tastes a little bit better, but in terms of health and in terms of really the water being drinkable, it would not make any difference at all. So it would be a relatively low marginal benefit compared to the marginal cost. So that's kind of why we think about this the way we do. Okay.